Now we are going to talk about the multiplayer aspect of my video game. You'll notice that there's the team players button and the single players button. We're going to be focusing now on the team players button. So, multiplayer. For those that are not familiar with multiplayer and its concepts, think of it as there's a server, and this server is responsible for facilitating information among all the clients. So my game may have 10 clients. That would be 10 players. And they all attach to the server, and then they begin to play. Anything that happens on any one of the clients, that information gets sent to the server, and then the server sends it to all the other clients. And that is the job of the server, to facilitate this information. As the servers get more sophisticated, they'll also take into account latency issues, delays, all the issues associated with multiplayer synchronization. So that's it, the concept in general. I chose to use the Photon Cloud system. And I chose it because it's one of the major players in the multiplayer world. Typically, smaller companies that create games, they can't afford to maintain a huge hosted server farm. So what they'll do is they'll buy time from Photon, and Photon keeps track of all the big services and servers and everything else that's needed. Now that's the paid service. So and that will allow you to register a server to be hosted on their system, and that mechanism is pretty good. I mean, it's very sophisticated, has lots of features, more so than the cloud. I chose to use the cloud version because it's free, and it does have some limitations. For instance, this concept of a client server, where you have a server and all the clients. In the cloud system, you can't host the server on their computers. So one of the clients has to be a server as well as a client. What that means is that, let's just say player number one is the first one to start the game. Since it was the first one, it gets assigned the server. So now player one is both the client, the player, and the server. And let's say you have 10 other clients that just logged into the system. And the game you're playing is a death match. So it's melee. And if player number one dies, then the entire game stops, because player number one is also the server. So clearly this is undesirable. So a melee type of game would not work well with the cloud. So there are other types of games that are very similar, and this is why it's free. I mean, it's good enough to get things going, but eventually, if you have a real good, sophisticated game, you're going to have to pay. So the servers, the Photon Cloud system has this concept of rooms. So what does that mean, rooms? Well, when you want to host your game, when you want to use the Photon Cloud, you have to contact Photon online, and you register your game with them. Once you register your game, they give you a unique ID. This unique ID now will be used to represent your game and only your game. So let's look at this in terms of a metaphor. So the Photon system is, say, a hotel. Your game is a floor, is an entire floor in that hotel. And there are other games, because there are other floors, but you're all separated. And each game has a series of rooms for their floor. Now, so when the floor starts out, there are no rooms. Then, the first person creates it, you have a room, and rooms start to be created, and then now you have many instances. So a room is essentially an instance of your game being played. And you can have 3, 4, 5, 6, 7, 1,000 people in that room playing this particular game. So that's pretty much the concept of how this works. So normally what's done is that you join the server, you're given the option, you enter the lobby. The lobby system gives you an option to say select a room that you want to play in. If none of the rooms are there that you want to play in, you can choose to create a room, and then now you create the room and you're in the room. So the method we're using is one of the methods recommended by Photon, is to ask for a random room. If the room doesn't exist, you create a room, and then you continue the gameplay. Now in our case, we have 2 players. There's only 2 players associated with this game. Player 1, player 2. So the first person that creates the room becomes the master client and is assigned player 1. Now, the next person that joins the game is assigned the slave client and becomes player number 2, and the gameplay begins. All right, so that's pretty much the concept. So let's get started. We'll go through the game first, show you some of the idiosyncrasies and associated with multiplayer game, and then we'll go into the code and we'll see how we address these issues in the code. All right, so come over to team play. I want to go team play. I'm the first one in. Notice it says waiting for players. This is because there were no random rooms. I created the room, and now I'm the only person in the room, and I can't play the game because we need people to play this game. So I have no choice but to wait for players, and since you see the wait for players. The cancel button is only there so that if you get tired of waiting, you can cancel and not wait anymore. All right, so let's start it with the one on the left, and you'll see it says waiting for players. Now, the one on the right decides to, okay, I want to play a game, I'm going to join the game. So they already found the room because they checked the random room because it already existed. There were 2 players in it, and the gameplay begins. Notice that the main screens are not coming up at the same time. These are issues you have to deal with multiplayer synchronization. This has to do with network speed, loading on the servers, at the Photon server, the type of computer the person has. You know, is it a fancy gaming computer? Is it an older computer? And so forth. So these are issues you have to deal with when you're doing your game. Now the question is, you know, at what point do I drop my player into the game? Well, once you know that both screens have come up and you've synchronized that, you want to wait some period of time before you drop your players in for everything to shake out. Because you always run the risk of, notice that the ship hit the asteroid, but the ship didn't destroy it, but it did show game over. Okay? This is a synchronization issue. The information that was sent to the server, to all the clients, which in this case there are only 2, did not receive the proper information, and since it was only checked once, the ship wasn't destroyed. Okay? So let's go in again. It says waiting for players. Now we go to ready. Again, notice the delay in which it's switching. So now once I realize that the screens have been synchronized, I'm waiting 10 seconds to drop in my ships. You're going to have to decide how much time you need. Is it 10 seconds, 15 seconds, 20 seconds, 30 seconds, and so forth. So in this case, the ship was blown up, and you saw it disappeared, and this is game over. If you set it for, say, 30 seconds or 60 seconds, then that would be too much time. The person's getting bored waiting. If you set it for too small of a time, then you're going to have synchronization issues, and your ship may just disappear because that memory that it's occupying just got cleared or freed up. So in my case, I chose 10, but maybe I should use 15 or 20. So that's a judgment issue, and that's some of the things you have to deal with. So let's go back into the game. It's waiting for players. So 2 players are in the game. So now it's telling the players to get ready. Okay, they're transferring in. First player shows up, second player shows up, and now the asteroids start coming. So you also have to take into account at what point you start the asteroids and so forth. Okay? And so you notice that the ship is tracking. This is something you have to take care of and can be an issue. So there are certain techniques that you need to do to make this happen, and we'll talk about those in the when we start talking about the code. Okay. If you watch closely, you can see a bit of a propagation delay between when one ship moves and the other one tracks it. That has to do with network traffic. So, okay. Also notice that the asteroids, like I said, are coming down. They're in the same place, same order, same number, same speed. All right. And so that's important. You have to deal with that. Also notice the score is the same on both clients. That you have to deal with as well. When I first did this, unless I used certain techniques, they were constantly out of order. One would register 100 points difference. There would be 100 points difference, 200 points difference between the two of them because of information that was just lost or dropped because of network traffic. Okay, so notice the ship was destroyed. It disappeared on both clients. And now it says game over. And notice also how long it takes to go to the home screens. Okay, so let's play this one more time. Another aspect of multiplayer mode is you've got to be realistic about how you're playing. So for instance, when this was a single player game, there's only one ship. So I could just fire the laser and do what I need to do and everything was fine. I only had to deal with the asteroids as objects to be concerned with. But now I have to deal with, not only do I have to deal with the hazards, I also have to deal with the particular ships. Okay? So, for instance, all right, so let's take this ship here. Let me just get this into a safe place. So, oh, these asteroids are coming down, aren't they? All right, so let's clear the way so I can show you. All right, so now this ship is going to, all right, you notice it said game over, but the ships are still here. There was a little action that happened here when the asteroid was destroyed. That's because the information was lost again, and the ship never got the signal to destroy itself. And at that point, because the ship didn't get it, it still doesn't. It's out of synchronized now. It's not synchronized, so it doesn't say game over anymore. See that? All right. So we're gonna have to start this game over again, and it looks like if I, let's see, can I get it to crash and move? Okay, there we go. All right. So now it registered. That was a idiosyncrasy you have to deal with when dealing with multiplayer. An approach would be to take advantage of the update event that gets executed on every frame. On every frame, an update event gets executed. So what you would do is that when you've gone through the move where an asteroid has crashed into a ship, you would set a flag. That flag indicates to the update routine that I need to check the game objects. Are both game objects null? If both game objects are null, then everything happened the way it was supposed to, and you're okay. If one of the objects is not null, that means that some piece of information was missed. So now you'll have to simulate that explosion and destroy the memory of destroy the resources of the ship or the asteroid, and set it equal to null. That way, the player doesn't see that this has happened because it's only happening on a frame. And as you move from frame to frame to the player, it's pretty much transparent. So you have to do these little checks along the way to take into account idiosyncrasies. Okay, so let's go in and play again. All right, let's see if we can do this before the ships get destroyed by some of the asteroids. Notice who dropped in this time. Okay, so not only do the laser bolts destroy, wrong one. Not only do the laser bolts destroy asteroids, they'll also destroy the other player's ship. So as part of the gameplay, you've got to avoid the laser bolts of your team player's laser on their ship. That doesn't exist in the single game mode, so this is something you have to take into account in the multiplayer mode. Also notice the order now. The transport, this side has gone to the main screen, but this side is just now starting to get to the main screen. And then I waited a period of time before I actually decided to drop the player in. And there comes the player. All right, so not only do you have to be careful of shooting, you also have to be careful of collisions. You notice that the only one ship disappeared when they both crashed into each other. That's an idiosyncrasy of multiplayer synchronization. The information got dropped that's supposed to tell the other client that a ship has run into you, that you need to destroy yourself as well. So same concept, you set a flag, and then you check it in the update routine to make sure that those explosions have happened what they're supposed to do. So we pretty much covered the game and some of the issues that you have to deal with, and you saw the effects of these issues. And next we'll go into the code, and we'll see how we compensated for movement, repeated laser blasts, keeping track of the timing of the loading of the screen, synchronizing screens, synchronizing the creation of hazards, and tracking the score. So we'll talk about those issues when we talk about and look at the code and see how it's formed. All right, well, let's get started on the code.